Our Earth invisible shield is failing.
NASA is tracking a mysterious region above the South Atlantic Ocean.
Satellites glitch out, and even astronauts see flashes of light with their eyes closed.
This region is known as the
South Atlantic Magnetic Anomaly.
What if I told you there's an invisible hole in Earth's defenses, and it's growing? A region where satellites glitch, radiation surges, and the planet's protective magnetic field weakens, almost as if someone punched a hole through it. What if I told you NASA is tracking it right now, and it's twice the size of Florida? It's not a movie plot. It's called the South Atlantic Anomaly, or SAA. And as of today, this magnetic void is expanding, raising real concerns about how it could affect satellites, astronauts, and even life on the surface of Earth. But what exactly is this magnetic void? Why is it getting bigger? And could it mean that Earth's magnetic field, the invisible force that shields us from deadly cosmic radiation, is beginning to fail? Let's go back to where this story begins. The invisible shield we take for granted. Every second, our planet is bombarded by high-energy particles from the sun and deep space. Solar flares, cosmic rays, bursts of charged plasma, all of them could sterilize Earth's surface in an instant if it weren't for one thing: our magnetic field. Generated by the churning molten iron in Earth's outer core, the magnetic field acts like a force field around the planet, deflecting dangerous particles and trapping others in radiation belts known as the Van Allen belts. It's the reason our atmosphere hasn't been stripped away like Mars. It's why compasses point north. And it's one of the few reasons life as we know it exists. But here's the catch. This shield isn't perfect. It fluctuates, it shifts, and in one particular spot over the South Atlantic Ocean, it's weakening fast. The birth of an anomaly. The South Atlantic Anomaly first caught scientists' attention in the late 1950s, during the early days of the space race. As satellites passed over the region, roughly covering parts of South America, the Southern Atlantic Ocean, and even portions of Africa, they began experiencing strange malfunctions. Computers would reboot, instruments would fail, data would get corrupted. At first, engineers thought it was just bad luck or perhaps solar interference. But as more spacecraft encountered the same problem, a pattern emerged. Something in that region was messing with the electronics. When scientists mapped the planet's magnetic field, they found the culprit: a dip in magnetic strength, centered off the coast of Brazil. In that zone, the field is weaker than anywhere else on Earth's surface, meaning radiation from space can penetrate much deeper into our atmosphere. And over time, it's only been getting worse. The growing void. NASA's Goddard Space Flight Center monitors the South Atlantic Anomaly closely, using data from satellites like Swarm, Icon, and Juno. They've discovered something disturbing. The anomaly isn't static. It's growing and splitting. In the past decade, scientists noticed that what used to be a single weak spot has now begun to divide into two distinct lobes, one over South America and another drifting toward Africa. In other words, the SAA is stretching out, expanding, and evolving into something more complex. It's now roughly 7.7 million square kilometers, about twice the size of Florida, and continuing to expand westward. NASA calls it a magnetic dent, but to satellites, it's more like a minefield. A satellite's nightmare. Every time a satellite crosses the South Atlantic Anomaly, it's exposed to intense radiation. Charged particles from the Van Allen belts slam into its electronic components, causing bit flips, tiny errors in data storage, or even permanent hardware damage. The Hubble Space Telescope, for instance, has to shut down its sensitive instruments whenever it passes through the anomaly to avoid corrupted images. The International Space Station, which orbits right through the edge of it, sees spikes in radiation levels. Astronauts report their detectors lighting up like fireworks during crossings. Even Earth-observing satellites, communication arrays, and GPS systems suffer increased risk. One scientist described it as a cosmic hailstorm of particles that can fry electronics at any moment. And since the anomaly is expanding, more and more satellites are being forced to deal with it. What causes the South Atlantic Anomaly? To understand why this happens, we have to dive deep, literally, into Earth's core. Our magnetic field isn't fixed or uniform. It's generated by the geodynamo, a swirling mass of molten iron and nickel about 3,000 kilometers below our feet. This liquid metal flows and convects, generating electric currents that produce magnetic fields. But these flows aren't perfectly symmetrical. They shift over time, causing the field above to wobble, weaken, or even flip entirely. In the case of the South Atlantic Anomaly, scientists think there's a pocket of reversed magnetic polarity deep beneath southern Africa, known as the African Large Low Shear Velocity Province. Basically, the molten material there moves differently from the rest of the core, weakening the field above it. Imagine Earth's magnetic field like a bar magnet that's slightly off-center. One end, near the SAA, is pushed closer to the surface, while the opposite end bulges outward into space. That uneven geometry makes the field thinner over South America, allowing radiation to creep in. It's a natural process, but one that's accelerating. Is this a sign of an impending magnetic reversal? Here's where things get really interesting and a little alarming. Earth's magnetic poles have flipped many times in the past. On average, it happens every few 100,000 years, though not on a strict schedule. When it does, north becomes south and south becomes north. During the reversal process, the magnetic field doesn't just flip instantly. It weakens dramatically first, sometimes dropping to less than 10% of its normal strength. That would leave Earth partially exposed to cosmic radiation for thousands of years. So naturally, when scientists saw the South Atlantic Anomaly expanding, many wondered, is this how a pole reversal begins? NASA and the European Space Agency have been cautious in their wording. They say that while the anomaly may be related to processes that could lead to a reversal, there's no evidence that it's imminent. Still, historical data show that similar anomalies often appear before flips. If the field continues to weaken at the current rate, it could reach a critical threshold within the next few thousand years, or sooner. No one knows for sure. Life under a weakened shield. Now you might ask, if the field is weakening, should we be worried about radiation on Earth's surface? The good news is, probably not yet. The atmosphere still provides a strong secondary shield against most cosmic particles, but for anything flying above it, satellites, astronauts, and high-altitude aircraft, the danger is very real. Radiation levels inside the SAA can spike up to 10 times higher than normal. This means more risk of equipment failure, more need for radiation shielding, and higher exposure for crewed missions. As space agencies plan longer missions to the Moon, Mars, and beyond, the anomaly has become a major operational concern. Every trajectory, every orbital path has to take it into account. Even commercial satellite companies have to design their systems to withstand the South Atlantic hazard zone. What used to be a minor technical challenge is now a billion-dollar problem. NASA's eyes in the sky. NASA's satellites are effectively the first responders in this invisible crisis. The Swarm constellation, launched by the European Space Agency, measures the magnetic field's intensity and variations with extreme precision. Juno, which studies Jupiter, has provided valuable data about how magnetic fields behave in fluid planets, insights that apply to Earth's core. Meanwhile, NASA's Goddard Space Flight Center has built sophisticated models predicting how the anomaly will evolve. Their latest findings? The SAA has deepened and expanded significantly over the last decade, with signs of continued weakening in the surrounding field. But there's also an intriguing twist. Some data suggests that the anomaly might be cyclical, not purely degenerative. In other words, it could shrink and grow as part of natural oscillations in the geodynamo, rather than leading straight to a magnetic collapse. It's like a heartbeat of the planet's core, erratic, powerful, and still largely mysterious. Cosmic radiation and the human body. For astronauts, the South Atlantic Anomaly isn't just an inconvenience, it's a health hazard. When they pass through it aboard the International Space Station, radiation doses spike to levels far beyond normal background exposure. These aren't deadly in small amounts, but long-term exposure increases risks of DNA damage, cataracts, and cancer. Some astronauts even report seeing flashes of light, phosphenes, when cosmic particles pass directly through their retinas. It's a humbling reminder that space is not a friendly place, and Earth's magnetic field is the thin line between safety and danger. Even on the ground during strong solar storms, the weakened region over the South Atlantic could experience increased ionization in the upper atmosphere, which might affect communication signals and navigation accuracy. We're learning that this anomaly doesn't just threaten technology, it challenges our understanding of how fragile our planet's magnetic shield really is. Lessons from history. Magnetic anomalies aren't new. Throughout Earth's history, the magnetic field has weakened, shifted, and reversed many times. During the reshape event, about 42,000 years ago, the field temporarily collapsed and reversed. For several centuries, cosmic radiation levels soared. Auroras appeared at tropical latitudes, and atmospheric chemistry shifted dramatically. Some scientists even speculate that these changes influenced human evolution and migration patterns. If something like that happened today, the consequences would be far greater. Our electrical grids, satellites, and communication networks depend on a stable magnetic environment. A major disruption could cost trillions and plunge parts of the world into darkness. The South Atlantic Anomaly, while not catastrophic yet, could be the early warning of a similar global magnetic shift. The mystery deepens. One of the most puzzling discoveries about the SAA is how fast it changes. Magnetic field measurements from 1970 to today show that the anomaly's center drifts westward at about 34 kilometers per year. That's faster than most tectonic plates move. It's also splitting, as mentioned earlier. One lobe drifting toward Africa, the other towards South America. This division could mean the processes driving the anomaly are intensifying, or that multiple regions in the core are interacting. Some researchers even suggest the anomaly could trigger localized mini-reversals, tiny flips in polarity confined to specific areas rather than the entire planet. If that's true, it would mean the geodynamo is far more complex than we've ever imagined, capable of producing intricate magnetic landscapes beneath our feet. What comes next? For now, scientists are watching closely. NASA, ESA, and several research institutions are building detailed simulations of Earth's core dynamics using supercomputers. They're feeding in data from satellites, observatories, and geomagnetic records that span centuries. Their goal? To predict whether the South Atlantic Anomaly is the beginning of something larger, or just another chapter in Earth's magnetic evolution. So far, the models show that while the field is indeed weakening, a full reversal isn't guaranteed. It could stabilize. It could shift and strengthen elsewhere. Or yes, it could continue weakening, leading to a slow-motion flip that reshapes the planet's magnetic architecture entirely. Why it matters to you? You might be thinking, I'm not an astronaut. I'm not launching satellites. Why should I care? Because the magnetic field is more than just a scientific curiosity. It's a fundamental layer of Earth's habitability. Every compass, every GPS signal, every power grid on the planet relies on its stability. Even migratory animals, birds, whales, and sea turtles use it as their natural navigation system. A weakened field could disorient them, disrupt ecosystems, and alter weather patterns by affecting how solar particles interact with our atmosphere. We often think of our planet as stable and unchanging, but the truth is, it's alive. It breathes, shifts, and evolves in ways we're only beginning to understand. The South Atlantic Anomaly is one of those breathing spaces, a reminder that even the shield that protects us is vulnerable. The edge of discovery. In a sense, the SAA is both a warning and an opportunity. A warning that our technology, so dependent on invisible forces, must adapt to the planet's own unpredictability. And an opportunity to learn more about Earth's inner engine, the same molten heart that's kept our world alive for billions of years. NASA's continued monitoring, combined with new missions like Swarm and Magnetospheric Multiscale, or MMS, will help decode the physics of the anomaly and, perhaps, give us clues about the future of the entire magnetic field. But even with all our data and simulations, the truth is humbling. We don't fully understand why the anomaly exists, or how far it will spread. And that's the unsettling beauty of it. Beneath all our knowledge, Earth remains a mystery, one we're still trying to read like a magnetic pulse echoing from the deep. Every time a satellite passes over the South Atlantic Anomaly, it faces a small moment of chaos. Systems flicker, circuits hum, radiation spikes. It's a moment that captures the delicate balance of our existence. How something as vast and powerful as our planet's magnetic field can harbor silent weaknesses that ripple through space. As NASA continues to track this invisible wound growing above the South Atlantic, one thing becomes clear. The story of the South Atlantic Anomaly isn't about danger. It's about perspective. It's about realizing that even the forces we take for granted, the invisible shields, the unseen protections, are in constant motion. The Earth beneath us is not a static rock. It's a dynamic, restless world, alive from its molten core to the edge of its magnetic skin. And somewhere deep below the core stirs again, sending its next magnetic message into space. One that we can only hope to understand before it changes everything. If you enjoyed diving into the mystery of Earth's magnetic field and want to explore more hidden forces shaping our planet and beyond, don't forget to like, share, and subscribe. Because what's coming next, from the depths of the core to the edges of the cosmos, might just rewrite everything we thought we knew about how our world really works. Stay blessed and stay curious.